Alright, I am going to go through a problem where we are going to find the GCF, the greatest common factor, and we're going to factor this expression. Alright, we're going to factor the GCF out of this polynomial here. So first we have to find the GCF. So if we look at each one of these terms, 15c to the fourth plus 24c to the third minus 6c squared. You could just look at that and find the greatest number that divides into all of those numbers and the variable with the smallest exponent, right? Or we can find it by using our prime factorization method. So our prime factorization method is, we're going to look at the numbers that multiply to 15. 3 and 5 multiply to 15. 3 and 5 are both prime numbers, so it doesn't factor any further. And then C, we're going to write that out 4 times. Right? And then 24, C to the third, we're going to do the same thing. Right, or factor it. It factors into 4 times 6. You could have used 2 different numbers, but then we're going to go further. We're going to factor it into 2 times 2, and then 6 factors into 3 times 2. So now we have a prime factorization for 24. We have 2 times 2 times 2 times 3, and then c to the third, we write out 3 c's. Right, but we aren't done. We have to factor out the negative 6. We have to factor that as well. Negative 6c squared. All right, negative 6 is a negative number, so we do need the negative 1 times 6. So negative 1 times 6, and then we can factor that further, because 6 is not prime, into 2 times 3. So we have negative 1 times 2 times 3, and then c times c for c squared. All right, we look at all of those numbers and all those variables, and we figure out what is in common on each line. And if we look at each line, we see a 3 on every single line. We do see a c, a variable c on every single line. But there's one more c, and every other line also has another c. So our greatest common factor here, our GCF, is equal to 3 times c times c, which is equal to 3c squared. Because c times c is c to the first times c to the first. Exponent rules tell us we're going to add those exponents so that it's 3c squared. Okay, we know the greatest common factor. So now we're going to take our original function, and we are going to, our original polynomial, and we're going to factor it. So let me write down the original polynomial. It was 15c to the fourth plus 24c to the third minus 6c squared, with a GCF, the greatest common factor, of 3c squared. So to factor it, so let me write out factored form down here. So factored form, we are going to write the GCF out front. So the GCF is 3, as we've already said, 3c squared. We're going to write that out front and then automatically put a parentheses. Then we take each term in our polynomial here, and we're going to divide each term by 3c squared. Divide every term by 3c squared. If we do that, 15 divided by 3. So this 15 divided by 3, that's equal to 5. So we're going to have 5. And then our exponent rules tell us to subtract the exponents. So subtract the exponents. All right, so we'll subtract the exponents. 4 minus 2 gives us 2. So we have 5c squared here. Do the same thing with 24, c to the third. We divide those numbers, 24 divided by 3. That gives us a positive 8. You subtract those exponents, 3 minus 2. That's c to the first. And we don't have to write the exponent of 1. And then do the same thing with the negative 6. So negative 6 divided by 3 gives us negative 2. And then the c squared. We have c squared divided by c squared. So those two cancel. And we get our answer here. 3c squared times 5c squared plus 8c minus 2. So that's an example of finding the greatest common factor and factoring a polynomial.